Right, shall we start?
Yes.
No time like the present.
Okay, so for anyone who hasn't been before, I think everyone has. This is our Twitter, email, and Discord. We are Rust and Cpp Cardiff, and we organise various meetups. We're always looking for new contributors. So if anyone has topics they want covered or speak talks they want to do, then please get in touch. We're here to learn, share, challenge ourselves, and kind of work together to generally improve our skills at programming in the languages that we enjoy. Several of us work for Esri, so they're our main sponsor, and they sponsor the meetup page. We have a code of conduct, but the short line is just be nice, be good to each other. We have a Pac-Man rule, which applies more in person, but just if there's a group, try and leave room for any newcomers to come and chat. And today we are going to be looking back on CppCon. Alex and Chris were lucky enough to be able to attend virtually while we were all waiting for the videos. We thought we'd be good to do a session, kind of hearing their impressions and the kind of key takeaways. So without further ado, I will pass over to Chris and Alex. If you want to take over the screen share.
Yes, please. I can't. You need to stop before I can. Thank you. Cool. All right. So so Alex and myself was sent with or without our permission to CppCon 2021, and this is kind of like our kind of takeaway from this event. It's kind of like our review. So this is our kind of like our personal opinions. So just kind of keep that in mind. Is there anything you want to add, Alex, before we kind of get underway?
Just that we'll be referring a lot to talks that the videos for which are going to be made available on YouTube at some point, hopefully in the near future. But I don't think they're all available yet, or even maybe a few of them are. But yeah, I'd say if anything sounds interesting to you, take a note of it, and if we discover that it's been uploaded to YouTube or it's been made public, however it works, we'll make a note of it in the Discord and let people know.
So, an overview, in general summary of the whole entire CppCon 21 was that it was pretty varied and quite a packed schedule. Wouldn't you agree, Alex? It was quite varied in its
yes.
in this level that it was aiming at. That those talks were aiming at. There was like a large scope, both introductory and experienced.
Oh, sorry.
Yeah, no, you carry on, Alex.
I was just going to say there was also quite a big variety in domains as well. So we saw a few talks from people working in the games industry. We saw people working in banking and some other industries that require sort of real-time systems programming, lots of embedded stuff as well. So it was a really good mix-up of different use cases for C++.
And I don't know if you would agree with me, Alex, on this, but there was kind of a real kind of sense that there were, the audience was quite divided. There was dissenting voices in the audience about the slow development of the new C++ features that were coming in from the committee.
That was definitely a recurring theme of the conference, the speed at which the new features for C++, which are frequently talked about and were demonstrated, as we'll get into later today, still are earmarked for 2023, and there's even chances that they'll get pushed to 2026. Lots of ideas in the mix that sound great, but ultimately you're still going to have to wait for years. And again, got it on a slide there, or maybe later, but a few attendees started asking questions like, why wouldn't I just use Rust? Because that has that today, which I thought was quite, I think one person asked beyond that, which is kind of cheeky, but yeah, no, that dissenting feeling was definitely present at the conference.
And what's interesting is that the Circle compiler, which I didn't really know much before about about CppCon, was showcased as as a C++ feature prototype compiler, and it's quite interesting because the mentality is very much okay. Well, if you're not going to implement these features into these compilers that already exist, we're just going to go ahead and kind of do our own. So Kira It will be showcasing some Circle compiler magic later on, and get better feedback on that. Just like Alex was saying, yeah, Bjarni suggested that Rust will kind of face similar challenges in the future to C++. So he kind of dismissed Rust really and said that, hey, it's still quite nascent and it doesn't kind of answer some of the long, more legacy challenges that C++ face. The question is that will Rust ever face those legacy challenges with Rust epochs? I mean, like, how do you feel, Alex? I mean, like, with C++ trying to support everything forever, and then Rust coming along with epochs. I mean, like, and then just dismissing anything that came before the epoch. It's interesting, isn't it?
I've got the ultimate cop-out answer, which is more data required. Time will tell, I'm afraid.
And I don't know how you felt, but I felt that the best talks were kind of more design and philosophy centric, but that's probably because of, where I am as a C++ developer in my career. But I don't know, how about you, Alex?
Yeah, I felt the same. But again, that would probably be down to personal taste.
Cool.
I do feel like there was lots of great talks out there for whatever you're interested in.
Cool. All right. So without further ado, we're going to look at our top 10 talks that we thought for CppCon. That was kind of like part one.
Yeah. So this is just to mention, these are not in any particular order, but these are just sort of 10 that Chris and I handpicked that we just thought were quite interesting. So the first one that we're going to talk about was led by a man called, I'm going to butcher the pronunciation now, Igor Boguslavsky. I hope I got that right. So his talk was titled Testing Compile Time Constructs Within a Runtime Unit Testing Framework. Essentially, he laid out a specific situation in which he wanted to test a library and ensure that a given function call could not compile. So, of course, normally if you wrote code that doesn't compile, your test code will not compile, and so it'll fail. And he wanted to make sure that he could actually check that case was catered for. So specifically, he was passing in, he had a function that took in a template argument, and he wanted to constrain it so that it was some kind of floating point value. So whether it's a double or a float or long, what have you. And he'd constrained it so that it wouldn't allow integers, and he just wanted to make sure that he had a test that when you pass an integer, it would fail compilation. And so he set out an approach that he took as part of his day job. I believe it was at a self-driving car research company. And he came up with a mechanism which was heavily tied to Google Test Framework, although I think it could probably be adapted for other systems. I won't spoil how he did it, but I encourage you to watch it. I don't know, Chris, I don't know if you saw that one, but did you have any other thoughts?
No, I don't think I did see that one. No, I didn't see that one. I will chime in with my feelings if any of these kind of come back to my mind.
Okay, lovely. So number 2, oh my god, I'm getting all the all the surnames I can't pronounce. Fedor Pikus with branchless computing. So in this talk, Pikus took us through a number of situations with real code examples in which your compiler will attempt to predict the result of a logical branch. So say, for example, an if statement. And he demonstrated the adverse effect that this can have on your program's performance when the prediction is incorrect. He also went through a number of different ways to verify that the problem exists through benchmarking, and just showed a couple of techniques on how to adjust your code to remove those unnecessary branches, and demonstrated the really quite significant performance increases you can get as a result. It was a really fascinating video.
Yeah, I love branchless computing. I love the idea of it. But what I found in his video or his presentation was very much, if you want to go full on branchless, it's taken a lot of effort to do it.
I think, I don't know if it's still around, but there was a website spouting this idea a few years ago called something along the lines of the No If Society or the No If movement. And I wanted to read about it at a previous job. And their their website blocking software thought it was some kind of political website and blocked it because it had the word movement or society or something like that in it. Anyway, so yes, number 3, Dave Steffen with the unit test strike back, which is this might be one of my favorite talks of the entire conference. It probably gave me the most concrete advice for unit testing that I've ever had since I first learned about test-driven development. And I'm trying to make sure that that's not, I want to stress that's not hyperbole or that's not me bigging it up more than it is. I think it was really brilliant. Stefan gave practical advice about unit testing, which takes into consideration real world problems. So you have this sort of nice example that you might see when first learning about test-driven development, which is, you know, yes, write your test, make it 3 lines if you can, arrange act assert, or if, when, then, whatever model you're learning. But in reality, you can't always do that. A lot of the time you're adding unit tests to legacy software. So essentially what he had laid out was a step-by-step plan, which is starting with the ideal. And if you can't do that, revert to plan B, revert to plan C. And he just spent the hour talking through just a wider range of techniques for unit testing in all kinds of difficult situations. And ultimately, the final thing, if you can't test at all, find a different kind of test. So consider smoke tests or integration tests, which would probably be another talk in its own right. There was a lot of content there, and I'll definitely be applying these techniques in the future. Number 4, Bjorn Strustrup. I always struggle to pronounce his name. Chris, can you pronounce it?
No, I'm the worst person to ask. I always call like Bernie, but obviously that's a butchering of his pronunciation. It's like, yeah, Bjorn Strustrup. Richard has the best pronunciation of him. But yeah, I just call him Bernie, which is massively offensive, and I'm aware of that.
So his keynote, Reaching for the Aims of C++, he gave a brief history of C++ and then converted into a look ahead to C++20. And he gave a bit of an explanation of how it ties up nicely with some of the original aims of C++. In particular, he referred to his 1990s book, Design and Evolution of C++. I think that's the title. I had it written down here and it's disappeared. But he mentioned how in that book, he outlined some of the key aims that he was trying to achieve with C++, and then related that back to C++20, the how C++20 meets those criteria. And that kind of sparked some interesting questions later in the conference, not just at this talk, but I think it also came up in Herb's one as well, asking questions like, is C++ complete now? To which the answer was a firm no. There's always more to add. He said we're not close to approaching the final form of the language, and C++ can and should improve. And yeah, he was pretty good. I don't know if you had anything more to add, Chris. I know you were quite interested in that.
No, I had a problem with that meeting because it didn't work for over half of it, so I didn't go back and watch it yet.
Yeah. That's also where some of the interesting questions about Rust came from the attendees as well. And finally, number 5, next day, the next keynote from Herb Sutter, extending and simplifying C++, thoughts on pattern matching. So he referred to C++20 as the first design and evolution, which is the name of the book I mentioned earlier, complete C++ standard. So C++20 is the first incarnation that actually meets the criteria laid out in the book. But he was also keen to state that C++ is not finished. He then went on to demonstrate his language proposal for C++23, which is pattern matching. And it looks pretty much identical to Rust, as we might see later. I think there's some conveniently named keywords just to make it not look a blatant copy paste, but hey ho. And I wasn't the only one who picked up on that. There were questions later who mentioned it. And They also mentioned the fact that Rust has that today, and Herb was saying that we're going to have to wait until 23. A few days later, at another talk, somebody who was outlining the additions to some of the other additions to 23 said that Herb's ideas probably aren't even going to make it into 23. So, there's a bit of grumbling from some of the attendees there. This was also the talk where Herb invited the creator of the Circle compiler, which we'll be talking about later, on stage. Chris, I can't remember. Did he come up 3 times overall?
It was quite a few times. It just wasn't just like, oh, hey, here's the guy with the Circle compiler. It was like he was trying to make a real statement. I don't know if I'm like, I know I'm full of hyperbole, but I'm very hyper aware of kind of like, I kind of got a real social situation going on here, and it was kind of shouting out to me that it was really sending a message that like, hey, the committee isn't trying to do things quick enough, and you got quote unquote competition from Rust. I don't know if you would call Rust competition. I would. I don't know if you would. But what's really interesting is that for me, in my hyperactive mind, is that this is very similar to in history when Martin Luther started rebelling against the Catholic Church and the Pope, and he just kind of went on his own way with what Christianity is. And I get the real kind of sense that we could be seeing history unfolded here. Like Herb Sutter might be saying, hey, no, we got a different idea of what C++ is, and that's with the Circle compiler. So yeah, in my overactive mind, that's certainly how I thought things were playing out.
I'll be honest, when watching it, I had some similar thoughts, but trying to think about it a bit more clinically later on, my suspicion might be that they might treat it as a prototype compiler, so people can try out concepts, give feedback. Maybe that could be used to improve the feedback loop for future ideas. Perhaps that can get things integrated into the language better. But that's all speculation. There was no signs of any of that.
Well, Kira's giving a talk later this evening about the Circle compiler, so maybe she can offer some insights into that.
Hopefully so. And part 2. We've got another 5 here that makes up our top 10. I know this one was one Chris was very fond of, Charlie Bay, the roles of symmetry and orthogonality in design. So Bay spoke about the idea of designing software through the lens of relationships within a system. So specifically, he talked about how they can be symmetrical, asymmetrical, or orthogonal. Some of these concepts are quite broad and abstract, but he was able to explain them really succinctly and clearly, and probably much better than I'm going to attempt to do now in a single sentence for each. But essentially, that's a short idea of what you could expect watching the video. We use the idea of symmetry to intuit what we don't see. So things like an example would be resource management. If we see a malloc at the beginning of a function, we expect a dealloc somewhere later in the code. And this symmetrical relationship makes the lifetime of an object clear for the reader. It's considered a strong relationship. We use asymmetry when we have a relationship that's unbalanced. And to quote Bay, we do this for fun and profit, but it usually means a shortcut. However, this prevents the intuition in the design that you would normally see from something like the malloc-dealloc pattern. We call that a weak relationship. And orthogonality is just when we remove edge cases and coupling entirely so that there is no relationship. And as I say, that's a really that might be really difficult to parse without seeing the whole hour's worth of video. But they had a very clear presentation style, and he had lovely diagrams to help when things got a bit wordy. Chris,
Yeah, no, I think you captured it pretty well, Alex. I think there was some additional language that he kind of used to suggest how much you can trust the code that you can see. And for me, this was my favorite talk because it really gave me a sense of it armed me with a sort of like a sort of language a design language that I can use with others, to really kind of standardize how we kind of talk about code on a line-to-line basis. So if you don't feel something is right about the code that you're looking at, you could probably slot it into some of the rules that he kind of outlined in his presentation, which I kind of really liked.
Yeah, definitely came away thinking I had some new tools for describing what I don't like about code. Is anything to make my life, to add complaints to my life is great. So yes, next we had, again, more pronunciation butchering. Gabriel Desriers and Cameron DeCamera. Sounds about right. It's a good symmetrical relationship in Cameron's name there. Implementing C++ modules, lessons learned and lessons abandoned. So this was an excellent overview on C++ modules, specifically with a lens of how to implement them in a compiler. The opening gave quite a few interesting metrics, particularly how they claimed that the compilation speed of a program using modules over a hash include could increase anywhere between 15 and 50 times, which is as big as it sounds. I think the first time I heard that, I thought that might be outrageous, but on further reading and later watching the video, I thought, no, it actually seems quite feasible. The concept of modules seems quite inspired by Rust's module system, but as Chris noted, more steps required. And they went through the development life cycle of modules briefly, with a touch on an abandoned approach for the Microsoft VC compiler. I don't know, Chris, if you had anything more to add.
Yeah, well, modules is probably the thing that I'm looking forward to most in C++20. And after you've gone through this top 10, I'm going to be giving a quick demonstration about actually getting modules working in your project, and be having a very quick live coding session looking at them. Yeah, I'll leave that for later.
Awesome. Number 8, I'm losing track here. Kevlin Henney, 6 Impossible Things. So very enjoyable talk. This is the second time I've seen Kevlin Henney live, and he always has a really nice, friendly, and somewhat sarcastic presentation style. So each of his 6 impossible things could have probably ended up being talks in their own right. But he basically went through each of his impossibilities, which I'll tell you in a minute, and gave practical examples in code of how, well, first of all, he proves that these are impossibilities. And essentially, he ended up sprinkling little nuggets of information just throughout the talk, with the topic ping-ponging wildly across each 6. It was the opening talk of the conference. So it was a nice little taster to get you in the mood for all things C++. So just as a quick summary, his 6 impossibilities were: representations can be infinite. Every question has an answer. Every truth can be established where it applies. The future is knowable before it happens. A distributed system is knowable, and technical debt is quantifiable as financial debt. So I won't go into any more detail than that. Hopefully that's made you curious enough to go watch this video when it comes out. Number 9 is Mike Sharp with the factory pattern. So he gave this talk as part of the Back to Basics track of talks. He provided a really nice walkthrough of the pros and cons and end goals of the famous design pattern. All of his examples were from the games programming perspective, which is quite nice for me. It's a field I'm familiar with, but it would have been nice to see some other applications of it. But it was just, overall, it was an entertaining and excellent walkthrough and nice refresher on the factory pattern. Very smooth. Finally, number 10, C++20, The Small Pearls, by Rainer Grimm. Grimm gave a run through of quite a lot of the smaller features coming to C++ as part of C++20. a lot of the other talks at the conference were mostly focused on the big four, so ranges, concepts, modules, and coroutines. So it was nice to just get a feel for what other editions are coming up. I'll probably end up referring to the video as a reference point in future, but I think, I mean, correct me if I'm wrong, Chris, I think either you or Richard might have given a similar talk along these lines at these meetups before.
I'm pretty sure Richard has. My talks are usually focused on C++ versus Rust, not necessarily C++ focused.
Well,
Yeah, I did do the after the Microsoft conference last year.
Yeah. Well, there you go. And that was recorded, wasn't it, Richard?
I cannot remember. Probably.
If it was recorded, you can watch that today instead of waiting for Rainer Grimm's. So if you really can't wait, I recommend you going on the Rust and Cardiff C++ YouTube group and having a look. It's no doubt excellent content. I don't know if there's anything you wanted to add about the small pearls, Chris, before we move on.
I think Richard covered it all in his presentation.
Okay, lovely.
Cool. Okay. All right. Well, that concludes our kind of top 10 takeaway presentations from CppCon 2021. So when they do get pushed out, those are the ones that we kind of recommend you checking out because there is a lot. Well, potentially there is a lot. Like there were 4 or 5 per day for a week. So yeah, that's a lot of presentations there.
Oh yeah, tons of content.
Okay. Cool. Right. Oh yeah, sorry, yeah, honorable mention, yes.
Ah, yes. So our secret number 11 on the list. So David Sankel, Up to Code. So this isn't strictly about C++, or at least the most interesting parts of the talk weren't about C++. But I just thought it would be worth mentioning because a lot of the discussion that took place after it was really quite interesting. So he basically started by giving a discussion where he compared the terms programmers and software engineers. And Sankel made the case that it's analogous to, say, a handyman versus an electrician, in the sense that one can fix stuff, so that the handyman can fix stuff, but the electrician is legally bound to do work to a certain standard and quality, and he has an ethical obligation to report problems and to do work to the highest possible standard. So with the electrician metaphor going on, said for an electrician, they might have a small job where they have to replace a wall socket, but because it's an older system, they have to know to use the older style of wall socket. Or they might have a big job, which involves replacing most of the house. So they have to know how to upgrade the electrical system and comply to all the latest safety standards and make sure that the sockets are brand new, the latest model. So with that in mind, he went on to explain how that applies to software engineering. He then basically went through a few programming patterns and paradigms in C++ that he reflected how he thought a software engineer under this definition would approach certain problems, which basically to ensure that the code that he's writing is up to code, which is, if you're not sure what that means, it's an Americanism as well, which basically just means get things up to standard. There was nothing particularly controversial about his suggestions, but the real interesting meat of the talk, as I said, came from the Q&A session at the end, when other attendees mentioned that there are lots of other professions where you're legally obliged to sign up to a set of standards or adhere to them and make sure that you demonstrate every few years that you're maintaining those standards. So things like people in the legal professions, lawyers certainly have to, I believe they have to pass the bar before they can actually practice law. Doctors have to be part of the doctor's register, or at least they do in the UK. I don't know about other nations there. And a lot of the attendees actually made points that they thought, while it's, again, in the UK, it's optional for software engineers to be a part of to be chartered. They think that it's inevitable that eventually will be legally made to register to a set of standards in the future. And in fact, they went as far as to say that if we don't enforce this now, if we don't start getting involved in the conversation, eventually we might have somebody force a set of standards upon us that doesn't necessarily work for us. And I think that's hard to argue against, really. If you think about the way like our personal information has become much more digitized and shared in the last 10, 15 years, you think of emerging technologies that have safety, like really big safety requirements, like self-driving cars or drone delivery systems, or even some of the big scandals that have come out in the last few years, like the Volkswagen emission scandal, which was ultimately software hiding the amount of emissions that the cars give off, or the Boeing software glitch that downed loads of planes. It's almost amazing that we haven't been forced to sign up to something already. So, I think this is something that's becoming more and more important for us to talk about and think about and consider. So Sankil's final slides kind of summarized his key takeaways, which were irrespective of code, which is that we need to consider that the software we're writing does put people, or can put people and property at risk. Software engineering as a field needs to mature, and we should consider ergonomics as a safety feature, in that you should make it easier for your code and your software to be used in a safe and correct way. He also went on to say that languages need to evolve to support, to better support software engineering, and he mentioned Rust specifically as an example where there are safety features built into the language. So another example of ergonomics as a safety feature. It's very hard to mismanage your memory with Rust, because it manages, or the compiler tells you so if you do it wrong. Maybe somewhat controversial for this group is that he also said that software communities tend to be based on languages, like the Rust and Cardiff C++ group, and that perhaps we should shift our axis towards making them about software engineering in general. But ultimately, the main takeaway is that the conversation about safety and software ethics needs to expand. I realize that's diverged away from C++ and Rust, and thank you for listening to that little rant. But I did come away from the talk with a renewed sense of purpose. And I suppose these two slides were my attempt at fulfilling that last point, expanding the conversation.
Appreciate that, Alex. So I'm going to rise to the challenge here and try to bring more questions to the table. If we were all chartered, would it mean that our careers as software engineers, would our careers become more valued? Would it become harder to get into becoming a software engineer because there's more hurdles that you need to jump through, and people already established, like us, maybe we find it easier to get chartered? I mean, like because software development is also so broad as well. It's like, what rules, what are the things that you put in place to say that, hey, this qualifies as safe, this code qualifies as safe? I mean, like, you're finding exploitation in code like every day, and like as one line of code is written, you're already introducing some sort of like bug into it. So, I mean, like, it's incredibly broad, isn't it?
It is. That's probably the key reason why the conversation needs to expand, because those are big questions and they need lots of people to think about them, to come up with sensible proposals. In some other industries, there's nice broad concepts like, for example, in medicine, do no harm. There's a pretty straightforward, clear-cut one, but it's also very vague. It doesn't actually go into any detail specifically about particular practices, which I think would be impossible given the amount of languages that are out there and the amount of different use cases. So perhaps it would be maybe just to confirm that you are continuing to learn and that you continue to act in a way in which you consider the ramifications of what your code is actually doing. But that's just me coming like ideas off the top of my head, by the way. I'm not actually making any predictions or anything. But I think it's important to maybe get the conversation going now, or to have it out there, because maybe somebody who sees an accident, maybe that, if there's another software, a famous or infamous software problem, maybe something that has dangerous side effects that happens, there may be a knee-jerk reaction by powers that be to regulate harder, possibly with less consultation. So it's probably, I think it's important to get that kind of these thoughts and ideas out there now, so that it's in the wider consciousness. So not just in our fields, but in other areas as well. As for your point about at what level do you think people should be chartered? Again, I don't know. It's likely that more and more jobs will involve programming in the future. So even if it was just a barrier to say, hey, there's somebody who knows how to write a script to interact with their Excel sheets at work, but don't let them work on a air traffic control system. If there was just something like that, that would even be a step forward.
I
So
guess with
there's
all
a long
these
way to
things,
say, I don't know.
the tricky bit with all of these things is making sure that whatever system you put in place improves the quality of software engineering rather than having the opposite effect, which is often introducing kind of arbitrary barriers. If they're, like I said, if they're not written by software engineers, then they could easily just basically stifle growth or become worse, box ticking. And then they're just a waste of people's time. You can be like a certified Scrum person. You can get certified with Agile and certified with Scrum. And although the course was interesting because I did it not that long ago, the actual test at the end felt like it was deliberately obtuse, and still passed, but it was like, it's the kind of thing what the reading materials they provided, it was like 18 pages or something, and it really could have been said on 2 pages, and it felt like it was trying to be more than it was. And it's like, what you want is resources that help people learn, that help people understand these best practices and make fewer mistakes, and an example of the electrician, don't burn the house down, and for us, don't drop planes out the sky or anything like that. But it's really hard to create resources like that. So I think you're right, having conversations starting early seems really sensible.
Tim raised an interesting point in the chat saying that, if you do something wrong as a software engineer, could you be disbarred as a software engineer? I'm like, that's a pretty scary thought and a position to be in.
That's true, but I suppose that also gives you the other approach as well, which is if somebody asks you to do something that goes against the standard that you have to adhere to for your chartership, you can't be punished for that. If you're legally required to meet that obligation and they ask you to do something that's essentially illegal, it would prevent the situation where the software engineers have to write something that hides it in the first place, and that's assuming that it's intentional. So if it's not intentional, then it's not. I don't imagine you'd be disbarred. I think my understanding is that the Volkswagen situation was that there was an active attempt to hide the readings, and I suppose if they went in and they knew it was unethical and they knew they shouldn't do it and they did it anyway, yes, could be disbarred. And if they came under pressure from their bosses, then that is something to resolve. But legally, I think the idea is that if you're signed up to such a scheme, or you're forced to legally follow the set of standards, and you're coming under pressure to break those, then you shouldn't. Legally, you shouldn't be allowed to be punished for that. Now, whether that happens in practice or not, I don't know. Again, it's a really good point to bring up. It's another facet to this that I hadn't fully considered.
These are, this is a really broad conversation topic, and maybe we should continue on in Discord. So if you want to talk about this more, maybe we can open up a chat in Discord, and we can talk about the effects of in the future of potentially and what would you describe this, Alex? How would you describe this ruling?
Let's just say the conversation needs to expand.
Okay, right. So conversation needs to expand.
I'll call the chat like chartered software engineering ? Or something.
Yes,
or,
yeah. If we can talk about it there.
Something like that might happen in the future, right? But it's not gonna be for all the.
Oh, you've muted.
something like that will happen in the future probably, right? But it's like the domains will be regulated. So not everything. Like if you write a software that sells books or sells something, maybe somehow, because it's still to do with the money, right? But if you do something just visuals or whatever that don't affect lives and whatnot, then it might not be charted. And then there might be a regulation that the software engineers that are hired for medical equipment, they have to be through some courses and have a experience of some years, proved experience that, I don't know, they really adhere to some standards, and the standard is kind of per language, right?
But
And-
you would hope that the manufacturers of that equipment, you know, would uphold standards, and they have their own medical standards that they need to adhere to, right? So, you know, where does the line draw, with the software engineers or with the manufacturers?
I mean, that would be in both, right? Because I guess they wouldn't be even able to hire someone who doesn't have a certificate of some sort, right? Like, so my wife is civil engineer, and to get a some kind of certificate of chartered engineer or whatever it is, right?
Yeah.
So she had to have like experience at the at just drawings and whatnot, right? So she had to have experience on the side, and then she had to go through a particular set of courses and whatnot, and then then she could only get a certificate, right? And I guess this is kind of raising awareness at this software engineer in software engineers, right? Like happy hackers, they might be great at delivering, but it's not always a software that, yeah, sometimes it can have a bug, right? And bug can have really bad effects on the users, right? And I guess following practices and learning to follow the practices, not cut corners.
I guess one thing you need to be careful of is if you raise the bar of entry for important fields like medical engineers, spatial engineers, you need to have the financial package that can encourage software engineers to go into that field, because otherwise you end up lowering the quality of software engineers because there's an extra barrier to entry, and people are like, oh, I can't be bothered to do that certification when I can earn X amount at this private company doing some really useless work, but it pays well. That might not benefit society, but it but it pays. So it's the balance. It'd be interesting to see where it goes in the future.
Yeah. Okay. We're kind of pressing on for time now, so let's take this conversation offline, and we can talk about it on Discord at length. And if people are really quite panicky about this conversation, maybe we can designate like a whole forum. Maybe you can do like a whole evening talking about this, because I think it affects everybody potentially. Yeah,
absolutely. Thanks for letting me run over time, Chris, by the way.
That's cool. All right, so we'll move on from here quickly. That is a blank page. Okay, so let's take a quick look at the C++20 modules. This is something that I'm really excited about because it reminds you of Rust. And I hate hash includes because I think they're quite archaic. So C++20 modules, I consider to be a modern approach to the archaic hash include. They promise faster compiler times, there's better namespace scoping, so everything that's inside a module doesn't leak out. So, if you've got a macro in a module, it's not accessed everywhere within your code base. So yeah, you got deduplication as well, which is great, which is kind of part of the faster compiler time. So every time you hash include something, all that code is kind of like brought into your file when it's compiled. With a module, it's compiled once, and it doesn't need to be passed like a hash include. So it's also because everything is like got these new keywords for module and import, there's potential for some better tooling as well, and some static analysis, which is quite interesting. So I was like, okay, these are all the reasons kind of why I love modules. So let's actually go and do one. Okay, so here, let me make that bigger. Cool. I'm slightly concerned that the UI might be a little bit too small. But we'll run with it at the moment. So let me know if you got readability issues. Okay, cool. So we've got a classic Hello World program here. This is using a hash include iostream. I'm going to run this, and what I've done, I put build times on. I should rebuild it actually. It's been a while since I've Visual Studio, usually in code. Okay, so it took us 1,760 milliseconds to build this hash include hello world program, okay? So just kind of keep a note of that. So simply just write that down, 1,760 milliseconds, okay? Now what we're going to do is that we're going to replace this hash include iostream with the with a module iostream. And there's a couple of things that we need to do before we do that. Now, the reason why I'm using Visual Studio is because I had so many problems with Clang on my Linux distro on Parrot. I tried installing loads of different libraries. I just couldn't get it working. So I was like, okay, well, what can I get it working on? And Visual Studio was the only thing I could get it working on. So I'm going to quickly show you how we can do that in Visual Studio. You need to open up properties. And under the configuration of properties, go down to C, click on language, and then you need to change the language standard to, and let's do the language standard, yes. C++ language standard needs to be the preview for the latest C++, and the experimental standard library needs to be enabled to yes. And there is also something else that I'm missing as well, but I've temporarily forgotten what that is. Okay, maybe it's under advanced internal general, hang on. Okay, all right, I'm gonna have to quickly, so I've got a backup project that can tell me advanced, yes, that's it. So the other thing that we need to do is go down to advanced, and we need to enable the module internal partition to be compiled as well, which allows us to, build the internal libraries for the C++ module. And this is interesting because we're going to get to this in a minute, but there's a difference there that needs to be made. So, okay, we just want to get iostream working first, and we're just going to compare to see its build times. So I'm going to comment this line out. Forgive me, I'm not used to not having Vim bindings now. But what we want to use, we want to use the imports, and then we just give it exactly the same thing. So iostream, and then we've got it in just like that. If I recall, that's everything that needs to be done. So if I just build that now, this is the moment of truth. Okay. Oh. Okay, I've missed something.
Is it the semicolon? Do you need that at the end of the import?
You're absolutely right. Defeated by one curly boy. Yeah, thank you, Alex, lifesaver. Okay, so let's look at the compile time for that. Well, it took maybe 1 second longer to compile than it did with hash include. Now, so it took 2,616 milliseconds rather than 1,700 and something milliseconds. Now, there is a couple of reasons why that could be happening. First of all, Clang already has pre-compiled standard libraries for modules, and it just kind of brings that in. So any benchmarking done is probably done with Clang to get faster compilation speed. The other thing as well is that this is just one file. Now, if we had a huge project where we're using hash includes for iostream everywhere, then the compilation speeds will probably be static around 2,000 milliseconds for iostream because it's already been compiled once and we don't need to parse it for each individual file, which is where the compilation speed slows down. So just kind of be wary of that. In this case, it's a very trivial example. We've got longer compilation times, but in a real world project, that's probably not the case.
Chris, I think this is importable header file. In fact, iostream. It's not the module from the standard library, right? Yes.
Okay. Well, that doesn't. Okay. Well.
I mean, so MSVC, it has something like std.io or something like that to import multiple things.
Well,
right?
that's how MSVC used to do it, and then they changed recently. I was reading a blog post about this that they changed it back to this. Now, I could be totally wrong, and you could be totally right. Oh, I apologize. I just been getting very cold. And Christoph's questions put a lot of stress on me. But yes, you could be right, Christoph. I'm not I'm just looking at modules here very quickly from a practical point of view. I just want to try something out, and this is just kind of my approach. Like I said, I had a lot of problems trying to get modules to even compile, so I'm just working with what's working. But the fact that this is compiling 1,000 milliseconds longer suggests that there is something different happening here. But what we want to do is maybe we want to write our own module. So that's what we're going to do now. So great, I've closed the other window. This is going to be interesting. So first thing to do when we want to create a new module, we want to add a new item in Visual Studio, which is a module interface unit. And we're just going to call this one my module, or my mod maybe. So here in my mod, we can export the module that we want, which is my mod. And then here we can export the function. So this is the it's like the definition file before we kind of declaration file before we define. So this is like our header basically. Now, what we want to do, what I suggest we do first, is actually put it in a namespace. So because if we don't, then everything can just be accessed in scope like normal, like publicly. So if we just do a namespace, then we just call it my mod, which is going to be different naming. And the reason we're doing it different naming because I want to show you that the namespace doesn't have to match up to the actual module that you're using. And then maybe we're just going to return an int from my func. I think this needs to be exported as well. So we export the namespace my mod, but we don't need to export the function inside. It's not like in Rust where everything inside the C++ module is made public by default, but everything inside a Rust module is made private by default. Don't hold me to that. I'm still learning. So we'll find out in a minute. So now we've kind of created our declaration file, our header. We need to make our definition file our source. So I'm just going to call this my mod.cpp. And in here, we need to import my mod. Yeah. And then we can do our namespace. My mod, and then we can write our function, which was, I think it was returning an int. My func. And then let's return 2. Right. Please, see, I'm used to Rust. Caught me out there. Okay, so yeah, so let me just double check that. So in our my func returning an int to my mod here, right? So in our main now, what we can do is you can also import my mod, and then we can just do a cout or something. So our namespace is my mod, so it kind of hooks onto there, and then we just got my func, if I recall it correctly, and it should print out 2 to the console. Now, before we do that, we need to change how these things are compiled. So if I right click on the source, is it the source? I can't remember now. I think it's the interface. If I click on the module interface, I have to compile it as module code, not an internal partition, because that is used for standard library code, if I recall correctly. So now if I run it, it's probably going to fail to build because I've probably forgotten to do something. Yeah. Okay, backup plan. So I've already done this already. I've already prepared one earlier. So let's have a look at that. So here we've got our my module, which is exporting to the namespace here, my module namespace. And here I've actually got a function called times2, and it's taking in a parameter and returning something which is declared here. So it's module, my module up here, not import. So if I just do module. Okay, let me try rebuilding that. Okay, still didn't like it. That's fine. I'll just use the starter project instead. So yeah, we got things in our namespace here. We got. I do need to export it. So yes, the namespace doesn't need to be exported, but the functions does need to be exported. That's my mistake previously. So yeah, so this is interesting. So this is a private function in the module, and then we have to export. So they are private by default, and you have to make them public to be exported to the module. So if you look at the main now, we're importing my module, and then we're hooking onto the module namespace to get #2. Now, if we didn't have this in the namespace, it would look just like this. So that is how we kind of work with modules. A very quick, my approach to kind of work with modules. A little bit hairier than I thought that they would be. It wasn't particularly like Rust. Before I kind of move on to kind of like the summary slide, is there anything that you want to talk about with this code, or anything that you want me to try before I move on?
If I recall correctly, I think you can export the namespace, and then everything what is in the exported block is also exported, but I might be wrong. Then the problem also is with the modules that you don't have a build system at the moment, I think, supporting it. Only build 2 or something, right?
Yeah.
Does the modules, and it's also doing it like in a not standardized way, and not it's not agreed with all the compilers.
Yeah.
CMake has modules for Fortran, right? And they were trying to adjust it for C++ modules, but that wasn't successful as far as I'm aware yet. So the problem with modules is that, like, for instance, MSVC here is giving you the option, but then you're really using a solution, right? MSVC solution. So now you're not cross-compatible, you're not cross-platform, but you're really hooked to your system, right?
Yeah. I mean, like that is something that I kind of found out, was that, you know, there is the tooling does not feel mature yet at all. I mean, like, it kind of feels like nobody's kind of really kind of agreed onto anything at the moment. And Emma's kind of VC kind of came out the blocks first and kind of did their own thing first, and then Clang and GCC kind of came on, and they're kind of doing things slightly different as well. And that's kind of how I feel about C++ at the moment, is that things are moving too slow in the standards committee, yet people are eager to start implementing features. And because there's no real standard on how to do it, they're just trying to do it how they feel. And that's kind of what I felt like from CppCon as well, is that a lot of people are a little bit frustrated. And now with Rust becoming more and more mature as well, I mean, like, there's a real kind of question as to the validity of C++ in new projects, but that is a topic for another time. Modules, yeah. So potentially compile times are only better for larger projects. The module interface unit feels a little bit clunky. I'm not particularly happy about that. It was not the Rust modules that I was hoping for, which is, you know, you just kind of put things in files and it kind of works out in kind of like in a tree-like structure where things are. And yeah, still got some way to go.
I've got one question in the chat, Chris. So we're saying, do you know how you import a namespace so you wouldn't have to use the long name? So, like, can you alias it or anything?
Yeah, good
I
question.
don't think so. When I was preparing the talk for modules, right, and then I just abandoned it because it was so clunky, really, and it just ate my life, right? But they were saying namespaces and modules are orthogonal, right? So you can define multiple namespaces in the module. Namespaces can span multiple modules, and it's just namespace is what it was, namespace before modules, right? But you cannot alias that.
You sure?
Maybe you can alias the module name, but definitely you cannot alias namespace.
Okay.
Namespace is as was.
Okay. All right. Thank you, Christoph. Okay, well, that was my very quick whistle stops tour into modules. Maybe I'll do another talk about it with Christoph later.
Can you do using? Like, so with using, you can have types, right?
Yeah,
alias
well, that's...
types. Can you?
Yeah, I'm pretty sure you
know.
can. I'm pretty sure you can use using. I'm getting confused with the Rust syntax now, but yeah, I'm pretty sure you can use like for example, just do mod. Is it as or is it equals?
Equals.
Yeah, equals. Yeah. So if we just do, let's just quick look.
I know you can do it for types, but can you do it for?
Oh, it's not like mod, is it?
Try writing namespace mod equals my module namespace. I think that genuinely might be the syntax. Change using to just namespace. Oh, so it looks like mods highlighted differently. Maybe that's the key.
Yeah, it is. Yeah, it
And
is.
Richard is just laughing at us now, probably.
Okay, and then try typing mod down with the times 2, or my mod, yeah. Is that gonna work?
Yep, there he goes.
There you
That
go.
works.
So that's kind of shortening it a bit.
Yeah.
You can
So there we go.
gets you some of the way.
Wow, I didn't know about that.
Okay, well, there, Tim, I hope I hope that roundabout way kind of answers your question somehow. But yeah, that is my whistle stop tour into modules. Maybe I'll look again in the future when a bit more mature. But now I'm going to hand you over to Kira.
But also, this syntax is not C++20. That must be earlier, right? The
Yeah, I
modules
don't
didn't
think that's
change it.
new.
Yeah.
But I'm not sure if you can just import specific functions with modules, because that would obviously then you wouldn't then need to use the namespace like that, maybe. But yeah, another talk for someone else. Okay. Circle compiler. This will be a very, very short introduction to Circle compiler. It's written by Sean Baxter. It is available on GitHub, and it is a C++ compiler that implements a lot of awesome C++ features. From my understanding, it came out of the fact that he wanted to make more C++ compile time accessible. So he allows you to interleave compile time C++ and runtime C++, giving you access to everything in C++ at compile time. And that's kind of I think the kind of origin story. But then since then, it does a hell of a lot. So as I said, you have access to all of C++ at compile time. And the way you say do this at compile time is using the @meta keyword. And that allows you to, interleave what you want done at compile time with what you want done at runtime. So in this hello world example, you're saying, okay, at compile time, print hello world, at runtime, print hello world runtime. And you can see the compiler stood out and the program stood out, which is pretty cool. And you can do that for tons of stuff. You can unroll loops. In an example we did on a video, he read a file, which could be super useful because sometimes there's just a file on your disk and you just want to do some stuff with it and then kind of bake that into the program that you're writing. But people have all sorts of hacky ways and you end up then just pasting the content in its more pleasing form into your C++ file so that you're not having to read it at runtime, which is not very nice. But if you can do this kind of merging, it's kind of taking it further than const expert. And one of the ways that sorry, just closed my slides. One of the ways he described it is unpicking const versus compile time, whereas const expert kind of intertwines them a little bit, so it doesn't necessarily, because it's kind of assuming that you want everything to be constant. It's like, well, actually I just want to do some stuff at compile time, just let me do what I want. So in this example, is able to then print an enum name at runtime. And I'll be honest, I don't fully understand all of the syntax used here. It seems like kind of learning how to use the Circle compiler would be kind of like learning to use a new language with some of the special features, but just taking some of the examples. So here you've got an enum class, then you create an array of some enums, and then that's created an enum to string method, which then will actually print the names. And that enum to string method uses this meta keyword to return the formatted string. And that's done at compile time. It loops over the enumerator and then creates a case statement for it. And then that way at runtime, because you can see this bit here, this is done at runtime. This isn't done at compile time. But because this is done at compile time, I can then use the name to generate this point. And I think most people have written an enum switch statement to string at some point for some reason or other, and it is kind of fun. So there's just little things like that. And there is, I can go to the example, but it works. It's not a lie. And compiles it, writes it, and it's not a huge amount of code. It's really quite nice. And then takes it further with list comprehension. Here you've got a vector and saying for I in the vector, if it's odd, then put it in. And the list comprehension syntax is I find much more confusing than the Python list comprehension syntax. It's trying to be the Python list comprehension syntax, slightly different, but there's a lot of cool things like this. There's just other functionality that they've added in. There's a range operator, which again, similar to Python. This is what happens when someone writes Python and they're like, I wish I could do this in C++. And they're like, I guess I'll write my own compiler from scratch and make completely open source. So here, range 10 prints numbers 0 to 9. Here you're saying go from 5 to 25, but only take the 5th number. Yeah, and then you can do things with it. This is summing. There's a lot of parameter pack syntax in the Circle compiler that I haven't quite got my head around yet. There's a lot you can do with it. It's very, very powerful. And then in addition to that, you've said list comprehensions, slices, ranges, for expressions, functional folds, expansion expressions, and just on the page of the GitHub gives a nice kind of list of some of the new stuff, doing stuff with CUDA, doing stuff with pattern matching, which I kind of mentioned before, doing stuff with member traits, circle conditionals. There's a huge amount of stuff that has been implemented, and it's now gone beyond just Sean Baxter. So now other people are contributing to it and playing around with it. It's very much not a production ready compiler. It's not really designed to be a production ready compiler. It's to make C++ more fun to write, but there'll be bits that won't quite work quite right or not how you expect. So unlike the C++ standard, which has gone through years of process of deciding it, it's very much a scratch pad. It's been implemented to do tons of stuff, and anyone can contribute if you want to.
Crucially, I don't think it's C++ feature complete either. It's very close, but I can't remember exactly which features haven't been implemented yet. But Baxter was quite keen to stress that at the conference.
Yeah, which I guess makes sense, and the ones that he's implemented are the ones that he thought were important. So it kind of then also highlights which bits of the standard maybe aren't as important as well, which is interesting. So why should we care about the Circle compiler if it's not going to be used in your production code? Why is it interesting? Well, it's become a real testing bed for future C++ features because it's so quick to add stuff to it, because it's been designed in a pretty modern way, and that's why it came up a lot at CppCon from what I've heard and seen. The example that was given earlier, so is this pattern matching, which we've kind of mentioned before, but there's an inspect keyword and there's the is keyword. So you can then say, test 3, is it 3? Is it in the range of 1 and 2? Is it this pair? And and that in the Circle compiler, which is available in Compiler Explorer, this syntax just works, and it's pretty nice syntax. And again, bits of it do look similar to Rust, but it is it is different, and it's quite clever. But then there is some it's maybe slightly more complicated than Rust to read, I would say, the Circle compiler code. When you've got for example, no, actually this is pretty straightforward. This one's not too bad, but some of the other stuff, like some of the list comprehension stuff, I don't find it as intuitive as some other stuff. In this example, so this is the one that gets a little bit hairy. I think this is the one they gave in the talk. This is an example of using the as keyword and the is keyword. So you inspect it, and then you get s as a short. If it is a short, then it prints it, and it's printing it using s as short, which is kind of interesting. So you see short's not one of the examples, but in the int example, it's then saying int 5, and that's taking I as int. So you're also aliasing it. And it's nice syntax, but then when you look at the when you look at some of the things that you then have to write, it's not the easiest to handle. But the Circle compiler has implemented these things ahead of them being in the standard by several years. And what that means is that if it's not right in the Circle compiler, they can change it, because they're not beholden to anyone, which I think is the real difference between having a mature language that says I won't change underneath you, and having a scratch pad like the Circle compiler where you can just do what you like a little bit. I'm sure that now more people are playing around with it. They're making an effort to make it a bit more stable, but that's kind of not the point. The point of it is to not be stable. The point of it is to be agile and adaptable, and be able to just pick things up and allow people to use it to iterate on features. So you try it one way, it doesn't quite work, you can then change it. Whereas it feels like sometimes with the C++ standard, it goes through all of these rounds of design kind of behind the scenes before the implementation kind of happens. And then you don't get a chance to play with it. Whereas if someone implements it in the Circle compiler, you can tinker with it. You can look at this syntax. You can say, is this how I want to use it? Is this actually useful in this way? Which is why it's quite cool, and it's available. You can download it yourself. It only seems to have kind of support for Linux at the minute, which is why I'm not doing demos outside of Compiler Explorer. But it seems fairly straightforward to install, and then you can use to your heart's content and get a feel for some of the new features kind of in the pipeline. As I kind of mentioned, so because it's easy to extend, Sean Bax has implemented some of the most promising WG21 proposals for C++ 23, and you can see the papers in there. And now when you're looking at these proposals, you'll see in some places it'll actually link to like Circle compiler in in Godbolt to show you examples, which I think is quite cool. And that really shows that it is a feedback loop. So in answer to kind of Chris's question as to whether or not the Compiler Explorer is going to overtake C++ standard compilers or the standard library, I don't think it will, because that's kind of not what it's for. If you wanted to write a new language from scratch, you would write something like Rust. You wouldn't bolt on things to C++. I think the point of bolting on here is to make it a bit more fun and to play around with it. It's a hobby project that has taken, it's got legs to be really useful, but I wouldn't say as a production compiler just yet. That was kind of everything I had to say on the Circle compiler. I can put links in the chat if anyone's interested, but they're pretty easy to find if you search Circle compiler. I want to mention as well the JetBrains video. I linked it in the chat already, but there are some already available, and the one that mentions is and as pattern matching. That is one of the videos available, so you can see Circle compiler being used in Godbolt. You can see Sean Baxter going up and talking about it, and yeah, we'll do a far better job of explaining it than I have. Yeah, that was kind of everything I had on that. Yeah, I'm sure there's room for a much longer talk on digging into any of those individual features, but if anyone is interested, so this is the website circlelang.org. It's got some great examples, and it has links to Compiler Explorer examples as well. See, a lot of the examples that I gave were just straight out of here, but you can also, sorry, I hit the little zoom bar. If you click on one of these links, it will show you the file, but there's also, the GitHub page. And here there's a huge number of examples. There's links to documentations and explanations of things. If you go into, for example, the comprehension one, there's a comprehension markdown, and this is the one that gives you a huge number of examples of all the stuff you can do with list comprehension, and the range syntax as well. So there's that range operator. I showed you the example of just generating the numbers, but the stuff that you're seeing in C++ ranges with the pipe operator to chain together those views, that's all in here. There's these for expressions. There's a huge amount you can do. So I would recommend, it's really well documented as well, which makes it really nice to read. I find it a lot more approachable to read than some of the C++ documentation for things, which can sometimes feel just like a list of functions. But yeah, I think it's a really cool project that's been going on for several years, and there's some great talks online from Sean Baxter about it. So I recommend them to anyone. And anyone might have seen just a second there. That was everything I had. We can do chat after, but I just wanted to mention for anyone interested, we have a Rust Book Club meetup next week, and then we'll be breaking for Christmas and coming back on the 6th of Jan. And we're looking to do more C++ talks in the new year. So if anyone wants to do any, maybe on the Circle compiler or anything you like, then yeah.
Who's doing the chapters 9 and 10 on Wednesday the 15th of December for the Rust Book Club meetup?
Actually, Richard's in the meetup. Richard, as much as you want to take, you can, but I'm also happy to take anything, so no pressure. Just
I was just highly relieved it turned out to not be tonight.
Did you think it was tonight? Oh,
I had that tonight in my diary.
Oh, okay, well, fab. And yeah, just let me know.
No, I'll be fine for next week.
Okay, fab. And are you taking both chapters?
Yep.
Very good.
I think they're chunky. I don't know if we'll quite make it, but I'll do my best.
Yeah, I appreciate it's a tall order to squeeze it into an hour. I know I won't be sad if it runs over, so no pressure on that front. But yeah, thank you, Chris and Alex, for talking us through some of the CppCon talk.
Thank you, Kira, for Circle compiler talk.
Just one thing on the Circle compiler and the compile time evaluation, or all the capabilities that C++ has. I remember CPP cast with someone, but that was like a half a year ago, or maybe even a year ago, and discussions about the compile time functionality. And this person was explicitly saying that the language shouldn't have all the features because it might be a security vulnerability, really. But you know, like if you compile your own code, well, it shouldn't really, right? And anyway, we know that Rust has that kind of in macros, right? Maybe it's more complicated, but it does have a way of running stuff within the compilation itself, and people are happy about it, right? So, I mean, there are just different stances, right, about that. And we know that the C++ community is kind of yeah, I don't know even how to say that, to be honest. But yeah. The problem with C++ is that if they introduce something and they find out it doesn't work, it's very hard to revert it, right? With other languages, like or with that Circle compiler, it doesn't conform to the standard. It doesn't have to, right? So they can add it, then they figure out, oh, it's been total bollocks. It's a problem. Just let's get rid of it, right? They can do it with Rust as well. There are no promises about stability, right? Whereas with C++ there are, and yeah, it is what it is, right?
I'm hoping that like going forwards, because like even like little things like Visual Studio making it easier to choose what C++ standard you're targeting, things like that. I'm hoping that things like that will make it easier to get rid of functionality in C++, and basically they just decide, it still needs to be a good argument, but deprecating far more,
I think there's a proposal about something like that. They called it epochs or something. That you basically specify a block of code and you say, I'm writing for this particular epoch. But apparently it didn't go anywhere. I think it was epoch.
Epochs have been an interesting discussion because that was something that lots of people were talking about CppCon, and it's something that I quite like, and I think maybe Alex likes as well. I'm not sure, but I'm pretty sure, correct me if I'm wrong, Alex, but didn't Bjarni say that actually epochs goes against, what C++ is about?
Yeah, he did say that, or I recall something similar. He definitely shut the idea down hard when he was directly asked about it. Yeah, was not a fan.
I guess there are somewhat things that would probably be straightforward to kind of convert from, you have something that was wrong before, you can now write it the right way, all the tooling will let you do that, but when it comes to compilation, it will then swap it out for you to the old hacky form. I'm sure there's ones like that the tooling could improve to make it nicer to write C++, and
but then you would have preprocessors.
Yes.
Converting to so you're
basically writing your own macros to swap out. That's true.
Yeah, but definitely epochs would have some problems with ABI compatibility.
Yeah. All interesting stuff. I've actually got to go, but if you all want to keep on the discussion, I can make someone else admin, although I'm conscious we have run over as well.
Thank you. Yeah, let's just end it there. I think. Yeah, thank you.
Tim, thanks for coming, and yeah, we'll continue any discussions on Discord and see you all. Yeah, hopefully at the next meetup and the ones to follow.
Right. See you all next week.
Thanks, guys.
See you then.
Bye.
Bye.